So now I give the floor to Professor Arnaud Fontanet from Institut Pasteur in Paris.
Okay, thank you very much. And it's my pleasure to be with you this afternoon. So I'm just going to tell you a little bit where we are going now. I think most of countries have gone through their first wave. And the question that we all have in mind is what is going to happen in the coming 6 months? And I will address these questions looking at other viruses, I mean coronaviruses, flu, and some modeling. So my first slide is indeed on the situation in France, where here you have the result of a modeling paper which has been done by the team of Simon Cochemez at Institut Pasteur, showing you where we were at the end of the first wave, with an epidemic which has been really important in the eastern part of France and in the region around Paris, as you can see on this map of the country. Overall, we estimate that about 4% of the full population has been infected during the first wave. And the R0, which is the basic reproduction number, the number of people that were infected by a case in the absence of measure of control, so at the very beginning of the epidemic, was estimated at 2.9. With that in mind, it is believed that the herd immunity, the total immunity required for the epidemic to stop by itself would be in the range of 66%. Next slide. If we were to understand what may happen at the end of this first wave, you know, now we had this lockdown which allowed to control the epidemic at a time we were very much suffering from the influx of cases in the intensive care unit. It may be useful to look at what has happened with other coronaviruses. I am showing you here a slide on seasonal coronaviruses from a cohort of Ann Arbor, Michigan, which tell you that those coronaviruses, which are responsible for mild respiratory infections and particularly the common cold, have, as you all know, a very clear seasonal pattern, peaking either in January or February. The two closest ones from the current new coronavirus are beta coronaviruses like HKU1 and OC43. But clearly those coronaviruses have already adopted a seasonal pattern. Next slide. The SARS coronavirus, the one of 2003, is depicted on the top of the right of this slide, and shows you the full epidemic curve throughout the epidemic of 2003. As you may remember, there were 8,000 people infected throughout the world, and about 774 died of the disease. You can see the first small peak is the one of Guangdong in China, and then follow the large peak which accumulates all the epidemic waves in different countries. The main country affected was China. As you can see here, the epidemic disappeared gradually in June and totally disappeared in July. The last cases were in Taiwan. It is clear that for this coronavirus, the control measures worked well because people were contagious a few days after onset of symptoms, so that the isolation measures were able to prevent transmission to others. And with strict control measures and also restriction of movement in some places, it has been possible to stop this epidemic. Some people argue, but without clear evidence for it, that eventually the summer may have played a role in controlling that coronavirus, but we don't have evidence for it. And as you know, the intermediate host, the masked palm civet, is no longer sold in the markets of China. And so there is no longer a chance of reintroduction into human population of this coronavirus. So hopefully we are done with this SARS coronavirus of 2003. The one that you see to the right down is a MERS coronavirus, and here are the different epidemic curves. This coronavirus circulates in the Gulf countries, and particularly Saudi Arabia. You have several epidemic peaks here corresponding to nosocomial transmission, and it's a bit unpredictable. There is no clear seasonal pattern. You can see in red the epidemic which took place in South Korea and which happened in May and June. So there, I mean, there was no evidence also of a seasonal pattern. So altogether, I mean, we have different pictures corresponding to different coronaviruses. I mean, some of them have taken a clear seasonal pattern, like the seasonal coronavirus responsible for minor respiratory infections, and for the other ones, we cannot say much. Next slide. One issue with the coming summer and the opportunity of becoming of having, if you want, I'm sorry, maybe the next slide. So one issue with the whether this epidemic will become seasonal or not is whether the temperature has an effect on it. And in laboratory conditions, the team of Malik Paris in Hong Kong does show for this new SARS-CoV-2 that it's less stable when you increase the temperature. So indeed, I mean, there are some reasons based on this to believe that eventually in the environment, and particularly on contaminated surface, that virus may be less stable if the temperature increase. So all what we have seen so far is telling us that when it comes to this summer, which is the situation in temperate zone of northern countries, there are some arguments to believe that eventually temperature may have an impact, and that this coronavirus would possibly adopt a seasonal pattern. The question is whether it will do it during this first summer, the one of 2020, or whether it will wait a little bit longer. Next slide. To address this issue, it is interesting to look at another respiratory virus, which has also some pandemic patterns whenever a new virus is introduced. And here I'm talking of the flu. If we go back 100 years ago on the Spanish flu epidemic, you will see that the first time it came, it did so with 3 waves for Copenhagen in Denmark. And you have on the top cases, then hospitalization, and then death. And you can see that there was a first summer wave characterized by an R of 2.2 to 3, pretty low case fatality rate, but with some excess mortality in the age group 15 to 44 years. The following autumn, so very quickly after, there was a second pandemic wave with this time a much higher case fatality rate, and again an excess mortality in the young adults, I would say, whereas the third wave, which was during the winter, had a sort of intermediate case fatality rate, and this time there was no longer an excess mortality that was specific to an age group. This excess mortality in the 15-44 years is a pattern that has been seen in many pandemic flu and corresponds often to this sort of inflammatory pneumonias that we do see again with this new coronavirus that starts during the second week and seems to appear at the time the virus is going down in the lung, but you have this very heavy inflammatory process starting. Next slide. If now I look to the more recent pandemic flu of 2009 and going to the US in the New York State, you can see that again, there has been a couple of waves, one in the spring and the other one being in the autumn or winter, and different size of the waves depending on where you were in New York State. But again, this pattern of several waves has been seen. Next slide. And if you look now what happened in the United Kingdom, again, we had 3 waves, which were first one in the summer, then the autumn, and the one was in the winter after, a year later. So again, all that to say that in this process of getting to this collective immunity that you need to stop the epidemic, you may have several waves. That is clearly seen with the pandemic flu. There can eventually be a seasonal pattern, and the pandemic flu 2001 of 2009 has become seasonal now. But as you can see here for the United Kingdom, it did not happen during the first summer. It did circulate when the collective immunity was small. For the pandemic flu, becoming seasonal is helped, and reaching the sort of critical immunity is held by the immunity acquired against other flu viruses. Whether for this new coronavirus, the other seasonal coronavirus will help in acquiring the herd immunity is something that is not known yet. So take-home message so far are maybe we can expect something a little bit milder during the summer related to the temperature, but also to the fact that during the summer, people are going outside and confined environment are very inducive for transmission. I'm not sure that this would be sufficient to prevent circulation of the virus during the summer, because even if that new coronavirus were to become seasonal during the first summer, it can still circulate. And yes, there are good reasons to believe that there would be second or third waves, because until we have reached the critical immunity that is required for the herd immunity, there is no reason that it would stop. And that is what pandemic flu is telling us. Next slide. Now to complete, I'm going to show you some scenarios taken from modeling work by a team of Harvard of Mark Lipsitch. A little bit complicated slides, but I'm going to take you through showing you different scenarios depending on how you apply the social distancing and to control the epidemic and to acquire the herd immunity. So if I go to the top figure A, what you see in dark is the number of cases, and you look to the scales to the left, which is the number of cases per 10,000 people. And in red, shifted by a small gap, you have the intensive care units hospitalization. And there you have to look to the scale to the right, which is around 1 per 10,000 individuals. What the strategy proposed here is what you have in shade blue or shade gray is a social distancing measure that would decrease by 60% the circulation of the virus, some form of barrier measures, physical distancing, can go up to confinement, whatever you need to reach 60% decrease in circulation of the virus. And the rule here is that whenever your red line of intensive care unit is reaching your critical bar of 80% of the total capacity, which is the total capacity is the dark line that is horizontal, and the dotted one is 80% of that. When you reach 80%, you put in place your social distancing to stop the circulation of virus because you want to stop the spread. And then you see that it goes down. And when you are down to a level where you believe that your intensive care units are operational again, you stop your social distancing and you see immediately number of cases rising as well as number of people going to intensive care unit. And you do this throughout the period, and gradually, and that's what you can see to the right, you acquire some cumulative herd immunity with the target of about 50% for reaching the immunity that would protect everyone. If you go to the graph number B, this is the same, but you apply during the summer a 40% decrease in the circulation of the virus. And you can see that you have a little bit of space between the time you have to put social distancing, but it remains quite intense. Now, if you go to the scenario C and D, it's exactly the same strategy, but this time you have increased your intensive care bed capacity to 2 per 10,000 K. So you have more time to let the number of cases go up before you decide to put your social distancing measure in place. And the graph D is the same with the seasonal effect of the summer. And here you can see to the right that you reach quicker your herd immunity, but still we are there in 2022 before we manage. At the same time, you realize that alternating social distancing and non-intervention is something that would be extremely difficult socially, but as well economically. I think the society would have a very hard time to bear with that. Next and last slide.
Thank you.
This is an alternative scenario where you have only one period of social distancing, but that can last either 4, 8, 12, 20, or an infinite period of time. And here you have exactly the same principle. Well, you just do your social distancing, you decrease by a certain amount the circulation of the virus, and you stop it, and you see immediately the rebound effect. And in this simulation, which takes some seasonal effect of 40% decrease of the Arnaud during the summer season, you see that inevitably you have a rebound after you have stopped your intervention. So the last one, the one at the bottom, the E scenario, is basically the one that we are currently doing in most countries, where we apply some social distancing throughout the period, trying to minimize the circulation of the virus. But of course, you don't acquire any immunity if your social distancing is effective, like up to 60%. So you are just maintaining a very prolonged stage of social distancing that can be economically extremely costly. So next slide. What shall we do now? I mean, you see that we are sort of locked into a situation where unless we maintain the control, the virus is going to spread and to be very damaging. And it's next slide. Well, the only option we have right now is to maintain the social distancing, hoping to avoid the second wave, because that second wave will happen if we lift the measures. And during that time, we look for a treatment and for a vaccine. Thank you very much.
Many, many thanks for also this very complimentary and very informative presentation. Thank you for respecting the time again. And so Professor Bruno Lina will then, during the discussion, answer your questions. Thank you very much for taking your time, and I wish you now another very fruitful meeting.
Thank you very much, Joris, and thank you, Bruno, for taking over. Bye.